Hello everyone, welcome to part 15 of this ongoing series on operating systems. So in this video we'll be talking about system boot. So once we have this operating system generated, so how do we know where this kernel is and how do we load this kernel? Because this kernel is itself the main component of the operating system, and the system will be powered on only when this kernel is loaded, because kernel has the functions which basically power on the entire system. So there must be some kind of way to find where this kernel is, and there must be a way to load this kernel into the RAM and then execute it. So this entire process of finding the kernel and then loading it to the main memory and then executing it is called booting. So there is a small piece of code called Bootloader basically, which does this. So it is the bootloader which finds the kernel and then it loads it into RAM and then executes it. And there are two ways of doing this, doing this particular process. So one is directly loading kernel into RAM and then executing it. Some computers also have two-step booting, wherein the first step is finding the bootloader would basically find a boot program. This boot program is stored in disk. So bootloader would find the advanced boot program which is there in the disk. It will then the boot program will be executed, and boot program would basically help in loading the kernel and starting the system. So we can directly load the kernel, or we can have this two-step booting process. So we'll just talk about how this entire process is working. So this bootloader, since this is a piece of code, it is usually stored in random access. I mean, in read-only memory. So this is burnt to ROM, so you cannot change this code. And whenever you power on the system, or say reset the system, so the instruction register will be loaded with some predefined memory location. This predefined memory location is the memory location of this bootloader. So once this bootloader is loaded, and its execution will start. So bootloader can also issue some kind of diagnostic commands to check the status of CPU registers, to see if main memory is proper. So all those diagnostic commands would be issued before starting the operating system. And if at all we have small systems like tablets, in that case the entire operating system can itself be stored in ROM. Instead of having only the bootloader in ROM, we can store the entire operating system in ROM. But this would be only suitable for operating systems which are quite small, and they interact with small simple hardware. Also, what if there is some kind of requirement where we need to change this bootloader code? Since bootloader is in ROM, we won't be able to change it, because this is read only. We cannot write anything to this code. So instead of using ROM, in that case, we'll be making use of EPROM. So EPROM is electrically programmable ROM. So by issuing some explicit command, you'll be able to issue writes also in case of using EPROM instead of using ROM. So we'll just talk about this boot process now. So we know that operating system is on the hard disk, and bootloader is in ROM. So bootloader, the main activity what bootloader has to perform is basically load the kernel. Kernel is nothing but a major part of the operating system, and kernel would have the ability to start the entire system. So the flow is a bootloader should find the kernel and then load it to RAM, and then kernel would basically start the entire system. So there is a specific block called the boot block. So boot block is this is usually the very first block on the hard disk. So when we say block, it is nothing but a unit of disk. So we'll just talk about what this boot block is. So when we talk about bootloader, bootloader will have some kind of code in it. It would be very minimal. The code would basically search for this boot block. Now what this boot block will have is, when we talk about this two-step process. So we'll just talk about two-step booting, wherein the first step is So assuming we have this two-step booting process, wherein the first step would be to find wherein this bootloader would find this advanced boot program which is stored in disk, and like in the second step, that boot program would basically load the kernel and start the system. So if we consider this two-step bootloader, I mean booting system or booting process, so in that first step, bootloader would basically find this boot block. So bootloader would have a code, but this code would only be meant for finding this boot block. It won't load the kernel. Loading kernel and all would be done by this boot block. So this bootloader might know the address on the disk where this boot block is present, which is like usually the first block only, and it would also know like the length of the remaining bootstrap code. So this bootstrap code, remaining bootstrap code, like loading the kernel and then executing it, that would be stored in this boot block. So the entire program, I mean, the program in this boot block would be sophisticated enough to load that entire operating system and then start the system. So for example, this grub is a bootloader for Linux systems. So once we have the bootloader, I mean, once the bootloader finds this boot block, the boot block would have that boot program, and that boot program will be running. So it would load that boot program into RAM, and then that boot program will indeed will in turn load the kernel into RAM, and then kernel would basically start the entire system. So this is how the entire boot flow happens. Also, there might be like a separate partition maintained on the disk wherein all these boot related code is like maintained. So if at all there is like any change required to the boot code, we can do those changes to this boot partition. So just to like repeat this boot process, so first bootloader would basically have code which would basically search for this boot block, and then boot block would have additional code which is more complex, and that boot code would basically find the kernel, and it would load the kernel to RAM, and it would execute that kernel. So kernel would then find the rest of the operating system activities. It would do the rest of the activities which are related to starting the entire system. So that is how this entire booting process happens. So that's it I had in this video. Thank you for watching.